Welcome back, everybody. We're going to finish up R.7 today with rationalizing denominators. We're not allowed to have square roots or any type of root in the denominator of a fraction. And the reason why is because if I had the square root of 3 over 4, well, I know how to cut a pizza or a pie or a board or whatever it is that we're looking at into 4 pieces. But if I had the opposite, I don't know how to cut anything into square root of 3 pieces. And so because of that, we don't know the exact answer to that denominator. We can't have radicals down there. So for rationalizing, to get rid of the radical on the bottom, whatever the radical is, we want to multiply by that. So square root of 3. Remember, whatever we do to the bottom, we have to do to the top. So square root of 3 times the square root of 3. 4 times the square root of 3. Those are not like things, so they sit next to each other. On the bottom, square root of 3 times square root of 3. They're both roots. I'm allowed to multiply the 3 by the 3 to get 9. Now that we've seen the square root of 9 down there, we can simplify that to 3. Remember that these are not the same. One's a square root of 3, one is an actual 3. So we can't reduce that. And if I look at the 4 and the 3, I can't reduce that either. And so this would be our final answer. We are going to change our letter B to the square root of 3 over the square root of 8. So I look and I see, can I reduce 3 and 8? Because they're both square roots. So if they had a common factor, I would try to reduce them. They do not. I cannot simplify the square root of 3, but I can simplify the square root of 8. And so I'm going to break that square root of 8 down. It looks like I have a pair of 2's that can come out with a 2 stuck inside the radical. So we have the square root of 3 over 2 square roots 2. Now I can work on rationalizing that denominator. Again, the radical that we want to move or get rid of is that square root of 2. So I'm going to multiply by the square root of 2 over the square root of 2. On the top, or the numerator, we can multiply 3 times 2 together because they're both underneath the square root, and 3 times 2 is 6. On the bottom, we have this 2 on the outside that is there. And then square root of 2 times the square root of 2, they're both roots, so we can multiply them to make 4. Remember, this is 2 times the square root of 4. The square root of 4 is 2, and so 2 times 2 is 4. We would check to see if we can reduce anything at this point. Remember, the 6 and 4, even though they have a common factor of 2, the 6 is underneath the square root. So it is not like terms with the 4 that's on the bottom, and so that is simplest form. Skipping example 11, we are going to example 12. And this time, we have subtraction underneath the bottom part of the fraction there. We have 1 minus the square root of 2. And so we've talked about conjugates before, and we need to use conjugates to rationalize here. A reminder of conjugates. Conjugates means that we're changing the sign in the middle. So if we had 3 plus the square root of 2, the conjugate would be 3 minus the square root of 2. If we had negative 11 minus the square root of 13, the conjugate would be negative 11 plus the square root of 13. So the very first term, the first number, does not change signs. The only sign that changes is the sign in the middle. So if I'm looking at the problem that's on our paper, we have 1 over 1 minus the square root of 2. The conjugate of 1 minus the square root of 2 is 1 plus the square root of 2. And again, whatever I do to the bottom, I have to do to the top. So on the top, we're distributing. 1 times 1 is 1, plus 1 times the square root of 2 is 1 square root of 2. You can write it with the 1 or without the 1 in front of the square root of 2. It's whatever you're most comfortable with. On the bottom, we're multiplying, distributing, FOILing, however it is that you love to multiply binomials. 1 times 1 is 1. 1 times the square root of 2 is 1 square root of 2. Negative square root of 2 times 1 is negative 1 square root of 2. And negative square root of 2 times positive square root of 2 is negative square root of 4. I have like terms in the middle. These are both the square root of 2. We have positive 1 minus 1. Those add to 0. We still have this 1 here. We have minus. And then the square root of 4 is 2. So 1 minus 2 leaves us with negative 1 on the bottom. And so if we simplify this, 1 divided by negative 1 is negative 1. And positive square root of 2 divided by negative 1 is negative square root of 2. And so this would be our final simplified answer. You have room for one more example. And so I'm going to add an example here. And let's do 2 over 3 plus the square root of 5. Our conjugate is 3 minus the square root of 5. Whatever we do to the bottom, we have to do the same to the top. So again, we are distributing, FOILing, whatever it is that you want to call it, on both the top and the bottom. 2 times 3 is 6. 2 times the negative square root of 5, negative 2 square root of 5. Remember, 2 and square root of 5 are not like things. They don't both have square roots, so they can't actually multiply. On the bottom, we have 3 times 3 is 9. 3 times negative square root of 5 is negative, sorry about that, is negative 3 square root of 5. Square root of 5 times 3 is positive 3 square root of 5. And negative square root of 5 times the positive square root of 5 is negative square root of 25. Again, because we've used the conjugate when we're FOILing or distributing on the bottom, those middle two terms should always be exactly the same but opposite signs. So when we add them together for like terms, they add to 0. We have the 9 here, we have the minus, and then the square root of 25 is 5. And so 9 minus 5 is 4. So we have 4. We do want to check to make sure if I can do any further reducing here. And remember, the square root doesn't count because it's not a like thing or a like term. 6, 2, and 4 all have a common factor of 2. So if I reduce 6 by 2, I get 3. 2 divided by 2 is 1, and 4 divided by 2 is 2. So that makes our final answer 3 minus the square root of 5 over 2. This is the end of our R.7. Thanks so much for joining me. Have a good rest of your night.